Hello and welcome. So in this video, we are going to implement a sentiment analysis model or a multi-class classification problem based on sentiment problem. Okay. So in this video, we are going to use the sentiment analysis for movie reviews dataset. As you can see right here, we have train.tsv, which we will be using for this model and for this problem. So last time I created a video on multi-label classification problem, and this is on multi-class classification problem. Now, if you want to know the difference between the two, that is the multi-class classification problem and the multi-label classification problem, you can head over to this blog, which has explained it in a wonderful way. So I'll provide the link down in the description to this blog. So basically the difference between the two is that in multi-class we will have only a single output at a time. All right. In our For our data, for a given amount of data, we will have only a single output class at a time. And if we talk about multi-label, a row of or a single text input can have multiple labels at once. Okay. So for more, if you want to go in depth, you can refer to this blog. I'll provide the link down in the description. All right. So let's get back to our problem. So here we are going to create a multi-class classification Bert model, okay, using TensorFlow and Hugging Face Transformers library. All right. So first step is to install the Transformers library. So I'll do pip install Transformers. So we have installed the Transformers library onto our Google Colab session. Next is to import the necessary libraries which we are going to use in this tutorial. So these are some necessary libraries. All right. Next step is to read our data. Okay, I will provide the data set in the GitHub link. All right, in the description. So here is my data set, which is of 8 MB. Okay, so we will use pandas to read our data. So here I have copy pasted the path of my dataset and a separator using the \t. All right. And now we will see the head of our dataset. As you can see, we have 4 columns. The first 2 columns are unnecessary and are not required by our model, but the third and fourth are required. Okay, which is the phrase, which consists of our text, and the fourth column, which is our sentiment column. All right. So let's see some info about our dataset. So for that, I will use the info function provided by the pandas data frame. So as we can see, the sentiment uh, sentiment column is integer. All right, but I have seen that it is float, so you can use the pandas utility to convert it into integer type. All right, because we need labels in integer form. All right, and the phrase is object because it is a string, and rest are integer. All right, so we are good to go and we are good to proceed further. So let's just see now in what proportion do we have the our target labels. All right, so let's just see df of sentiment dot value counts. All right. Okay, so as you can see, our zero class has 7,000, fourth, 1, 3, 2, etc. All right. So this is somewhat an imbalanced data set, but we don't care for now because we are targeted towards the multi-class problem for right now. Okay. Later we can discuss how to uh, make sure we have a balanced data set and not an imbalanced data set. By the way, I have already created a video on handling an imbalanced data set, which I will be providing the link for the same down in the description. All right, cool. So let's see what labels belongs to what class. All right. So this is I have taken from the dataset itself, all right, from the summary or from the description, as you can see here. All right, so 0 corresponds to a negative class, 1 corresponds to somewhat negative, and so on. All right, cool. So the next step is to initialize our tokenizer from the Bert model. Okay, so let's just say tokenizer is equal to Bert tokenizer dot from pretrain Bert base cased. All right, I've already explained what is tokenizer in my previous video. You can go to my channel and visit that video. All right. So right now I won't be going into much detail about the tokenizer and the bot model. We are just going to focus on the implementation in this tutorial. All right. Cool. So let's just hit enter and execute the following cell. So we have successfully initialized our tokenizer, bot tokenizer especially. So let's just see how this tokenizer works. All right. So for example, we have a sentence. Let's say phrase. I'm just taking a random sentence from our df column phrase. Let's just say the 0th sentence. All right. So as you can see, this is our 0th sentence. All right. So we are going to uh, tokenize this sentence using the word tokenizer. So as you can see here, I have provided the text, the input text here, and the maximum length for which it should tokenize a sentence. Okay, that is 256, but the default is 512. I have just made it 256 in order for the easy computations. You can obviously play with it with this value. Okay, truncation is true, padding is max length, and add special tokens is true. Special tokens are basically the CLS token, the padding token, and the separation token. All right, cool. And the tensors I'm returning in the form of TensorFlow. All right, cool. So let's just see what it returns. So it has executed successfully. Let's just now see what we have got. So if I just uh, input token, so we have got input IDs. All right, we have got token type IDs and attention mask. All right, our BERT model needs input as input IDs and attention masks. Okay, okay, we don't need token type IDs for right now. Cool. So as you can see, these are approximately 256 length of vector. All right, and wherever we have a word, we have a number or an index. You can say this index corresponds to a longer embedding, which is known as BERT embeddings. Obviously, okay. So we won't be going into much detail about that. Otherwise, this tutorial will go to a far length. Okay, cool. And 0 corresponds to our padding token. All right, as we have known about the special tokens. So as I told you that we will be needing input IDs and attention masks for our input to BERT model. Okay, so we are now going to create those vectors or arrays, you can say. So we will create 0 vectors or 0 array for our input IDs and attention masks. All right. So as you can see, the length of the DF, the first number of rows will be the amount of or the number of samples we have in a data set. All right. And each row will have how many columns? 256 columns. All right. The maximum length of a sentence. Cool. And same goes for the input IDs and attention masks because both the dimensions of both the vectors are same. Cool. So let's just see the input IDs shape. As you can see, the number of samples and for each sample, how many columns. Okay, that is the length of each sentence. Cool. So the next step is to generate the training data. So we are going to populate all the tokens converted using the tokenizer.encode plus method in the input IDs and attention mask zeros vector. Okay. So I'm going to make a function right now. So here you can see I'm expecting a data frame the input IDs and the attention masks and the tokenizer, which will tokenize our sentences. Okay. So first of all, we will iterate through our df of phrase column, which consists of all the sentences in our data frame. All right. And then we will encode it one by one. All right. Using the same parameters as we have used here. All right. So after tokenizing it, tokenizing it, we are going to populate all the input IDs and all the attention masks that we have created earlier using the np.zeros method. All right. So we are going to, so what this operation does is for every ith column, sorry, for every ith row, that is, for example, we are in this first row, we are going to append or we are going to populate all the input IDs of first row. All right. And similarly, same for the mask. And then we finally return all the IDs and masks. All right. Cool. So let's just see how this works. So now let's just run this command to populate all the input IDs and attention masks. Okay, we are done now. So let's just say see the shape again, or let's just show the whole input IDs array. So as you can see, it has now filled with all the input IDs we had here. All right, all the tokenized input IDs. Cool. Instead of all the zeros that we defined earlier. Uh, so now we have to define the labels arrays also, right? So it will be the same dimensions, that is labels np dot zeros, and shape would be length of df2. Let's just see how many classes we have. We have 5 classes, all right. So the output should be so the length should be 5 here. Okay. So we are going to use this labels as a one hot encoded target vector. All right. So I hope you know what a one hot encoded vectors is. It is basically a vector in which, for example, we have 2 classes. All right. Let's just see. For example, I have 2 classes, 0, cat and dog. Okay. Dog, which corresponds to 1, and cat corresponds to 0. All right. So what a one hot encoded vector does is, for example, we have here just a second. Okay. So for example, we have 2 images. Okay. So for the first image, we have it is a cat. All right. So instead of 0, we have here 1. All right. For the second image, if we have dog, we will have a 0 1 at 1 index. All right. So here, so this is what a one hot encoding looks like. All right. Wherever the class is, that index will be put as 1, otherwise all 0. All right. Suppose we had more classes. Uh, let's just say cow 3. Okay. And what else we have? Chicken 4. So we will have 4 vectors, 0, 0. All right. Here 2, 0, 0. All right. So let's just say we had another image. Okay. And now it was cow. So all the others will remain 0, but only the cow will be showed as 1. All right. So 0, 0, 1, 0. And suppose the next image consists of only the chicken. So it will be 0, comma 0, comma oops 1. All right. I hope you understand what one hot encoding looks like. Cool. Okay. Well, let's just see the shape. Okay. For every sample, we have a output vector of 5. Okay. For each class. Now we are going to do the same operation as I just told you, right? For wherever we have a 1, or wherever we have a number, we will encode it as 1, and otherwise 0. All right. So now you can see I have this is the logic that I have come with. So this will help me to encode the labels as a one-hot encoded label vector. Okay. So let's now see the labels, what it looks like. As you can see, wherever I had a value, for example, the first text was 2 class. All right. So it has populated that second column to be 1 and else all 0. And this similarly all the same. Okay. Cool. So let's head over to the next step. Next step is the data creation step using the TensorFlow utility function. That is the dataset model. Okay. So using the TF dataset from tensor slices, it will help us to create a precise and efficient dataset model, which will help us to iterate it and provide us with batches. All right, which will ease up in training process. Cool. Now let's see the shape of this dataset of one example. So as you can see, the first batch will have 256, and sorry, not the first batch, a single example. This is the shape of a single example, all right? So it has 256 tokens. This is attention, sorry, this is input IDs, attention masks, and the labels, all right? Now we are going to create a map function which this dataset expects to return the batch, all right? So for that, I have already defined a mapping function. Here we are just going to change the return type. Okay, so sorry, not the return type, like how the function returns it. All right. So as you can see, I have just reformatted how the function should return. All right, this data set. While when we will be training, this will be used. Okay, this is how the output will be returned to us. Cool. Input IDs as input IDs, attention masks, and labels. Now let's just apply this map function to our data set. So now if we take a look at the shape of one sample, it will show us the input IDs 256, attention masks, and the where is the label? Yes, and the label. All right, here. Cool. Because earlier we only had the shapes, we didn't have any uh, keys. Okay, but now we have them. Cool. So that was the only purpose of a map function. Next, we are going to shuffle the batches or the training data set and provide a batch size to it. All right. Drop remainder is basically used to left out any tensors. Okay. For example, if we divide 16, because we have set our batch size to 16. So, and we have, for example, we have 33 examples. Okay. So by dividing the batch size by 16, okay, by dividing the number of samples by batch size, we will be left with a remainder of 1. Okay, so this drop remainder confirms that we got no 1 left in our data set. All right, so it will eliminate that 1 sample from our shuffled data set. Next step is to define how much data I need to have for my training set. Okay, for example, I want to have only 80% of the data set as my training data set and rest the validation data set. All right. So here what I'm doing is I'm allotting 80% of my this data set to training data. All right. And the left 20% for the test data. All right. Now let's see what train size we have. So oops, size. So as you can see, we have 7,802 training data as training data. All right. Cool. Sorry, data as training data. All right. Cool. So the next step is to create this train data. All right, because this is just the integer of our training size. All right, now we have to split our data set into train and validation. All right, so this piece of code will take care of that. So we will say that take data set of train size, which will be equal to the train data set, and the left 20% will be of validation data set. Okay, so the preparation of the data is finished. Now we will move on to the next phase, that is the model creation. Okay, So we will take help of the TF Bert model from the Hugging Face Transformers library. So we will say that transformers import TF Bert model, okay, and we will say that Bert model is equal to TF Bert model dot from pre-trained say Bert base cased. All right, and press shift enter to download the model onto your collab notebook. Cool. So let's now create our model, all right, using the Bert embeddings. Cool. So I'll be using TensorFlow for creating the model. You can also use PyTorch too, but I find TensorFlow much easier sometimes. Okay. Yeah, so we will have two input values. That is the two inputs to our BERT model. All right. That is, first is the input IDs and the second is the attention masks. All right. So we will say that input IDs will be equal to tf dot chaos dot layers dot input, okay, and shape will be, the input shape should be equal to the where did the shape go? Yeah, this one, right? 256 input IDs, the shape should be 256 comma empty, and for the attention marks the same. All right, cool. So shape would be 256 comma, and let's say the name of the layer will be input IDs. All right, and d type int 32, and similarly for attention mask. Cool. So this will be the two input to my BERT model. Cool. Let's now define the intermediate layers. All right. So after the inputs, I will implement the BERT embeddings using the BERT model that we just defined above. So this is our BERT embeddings layer using the BERT model here, which we defined earlier. Okay. And now it provides us two outputs or dense vectors. The first is the pooled output layer, and the second is the activation layer. Okay, sorry, it is the opposite. On the first index it is activation layer, and on the second index it is pooled layer. All right, so in this I will be using the pooled layer. You can also experiment it with the activation layer. Okay, so one stands for the second item inside the list, that is our pooled layer output. Cool. So this is our BERT embeddings. So the next layer will be our intermediate layer, okay, in our model. Intermediate layer be equal to tf dot keras dot layers dot dense, and here we will have units, let's say 512 units, and activation will be relo, name will be intermediate layer. Yeah, and it takes an input of this layer, that is the BERT embeddings. Okay, this is the format of TensorFlow Keras building model. Okay, this is how we build the model in Keras. Okay, and now the final layer, that is the output layer, will be, I'm just using one intermediate layer. Okay, you can experiment it yourself with more number of layers and some additional layers to, like batch normalization, dropout, etc. All right, I'm just showing you how to do this. Cool. Now the last layer will be tf.keras.layers.dense. We will have 5 units as we have 5 classes to classify. All right, here we have 5 classes, so that is why 5 units in the output layer. And here the activation will be softmax, because we need to calculate the probability of each class. All right, and it is the final layer. This is actually the classification layer, so that is why we need a classification activation function, that is our softmax, which is based on calculating the probability. Okay, and name will be the output layer, and this will take the intermediate layer as input. Cool. So this is our whole structure. Now we will combine this and create a model out of it. Now we will say that model is equal to df dot keras dot I'll say layers dot, no, it is not in layers. I think it's in model. Yeah, inputs will be my two inputs, that is our input IDs and our attention mask. Okay, and the outputs will be output layer. Okay, now model dot, you can see the summary now. Okay, I think we are cool. Okay, now you can see our model is ready, okay, to be trained. As you can see, we have the name to be intermediate layer, the output layer, okay, and this is all the trainable parameters that we need to train using our data set. So the next step is to define the loss function, the matrix, and the optimizer. All right, so you can see that I have defined the optimizer, the loss function, and the accuracy matrix as follows. Okay, this is here I am using the Adam optimizer, and here I am using the categorical cross entropy loss function, because we have this is a multi classification problem, and similarly for a categorical cross entropy we will use categorical accuracy. All right, cool. Now finally we will compile our model using these parameters. So model dot compile, here we will have optimizer is equal to optim, and loss loss is equal to loss function, and matrix is equal to accuracy. All right, cool. Now our model is compiled, and now we are ready to train it on our custom data set. Now we can train the model using the fit argument, using the fit method. So this will take our training data set and our validation data set, and I'm going to train it only on 2 epochs, because right now I'm recording, so it will take much memory, and this is not a very good GPU I have right now because it is in collab. So you can experiment it yourself and make sure to train it on more epochs, like 20 epochs or 25 epochs. Okay, but right now for the tutorial I'll train only on 1 epoch. Okay, but that might also be too long because the GPU is not very good right now. Okay, so let's press shift enter to train it. So as you can see, the execution has started here. So yeah, very soon we will see some output, that is some epochs here. As you can see, the accuracy is around 20% and decreasing. It will take time, guys. Okay, as you can see, it is now 25%, 29%, 32%, and 33. So as you can see, it will take around 3 hours, approximately 3 hours for a single epoch. So you can see how heavy this model is and how much time it will take if you train it for at least 10 epochs. All right, 13 hours. So yeah, this is how you can create a model and train it on your custom dataset or a multi-class classification problem. So now I won't train it further because of the time sake, and I have to create this video, but you can see how you can do this and you can put it on train yourself. Okay, so I'm gonna stop this right now. Okay, cool. Just ignore the error because obviously I stopped it in front of you. Cool. So the next step, how do we save this model? Okay, and next how do we load this model and test it on a raw dataset or a raw text example. All right. So for saving the model, we will use a simple method which is provided by Tensorflow Keras. So we'll say that model dot save. Okay, save and put the directory here. Okay, I'll just write sentiment model. Okay, just hit shift enter, and you can see after some time it will save here. Okay, you will see the folder here. Cool. And the next step is to how do we load the model. So we can load the model like this. If you open a new test file or a new collab notebook, so you can use this like this. Loaded model will be equal to tf.keras.model, I think. Okay, so just let it finish the execution first and then we will load it. Okay, cool. We have successfully saved the model. So as you can see, this is our sentiment model and we have many folders and files here. So the main is this one, I think. Let's see the size of it. No, yeah, this one actually 1.2 gigs. All right, you can see this is a very large file. Okay, cool. So how do we load this model? All right, so you can load this model using the tf.keras dot, I think it's model. Yeah, it's model and load model. Yeah, load model, and just put down the directory here, sentiment model. So this is how you can load the model. All right, just hit shift enter. Okay, so we have successfully loaded our trained model. So next step is to actually predict some output based on a input given by the user. All right, so if I input any text like this was really a bad movie, it had no plot. Okay, so the first thing I would do is to pre-process this text input like we did during the data preparation step. Right here we need to tokenize this in the same way like we did while doing the generate training data process. All right, because the format should be same. All right, like how we used to train the data, the same thing would be to test the data. All right, so that is why we need to tokenize it first in order to feed it as input to our model for prediction. Cool. So for that I'm going to define a function that will do the pre-processing step. So here you can see I'm doing the same thing as we did earlier. We are going to tokenize the input text. All right, and then we are going to just change the return type. Okay, according to our needs. Cool. So if I now prepare my input text, would be tokenized input text. So prepare data, and here I will feed my input text as the input text and tokenizer. Oh, input text is not defined. Oh, I didn't run this cell. Now I run it. Okay, now let's see the tokenized input text. As you can see, this is the attention mask and this is the input IDs. All right, cool. So I need to feed this tokenized input text to our model now. So I will get the probabilities. I'll write props is equal to model, actually sentiment model. No, what was it? The loaded model. Loaded model dot predict. Here I'll pass my tokenized input text. Okay, and yeah, Okay, we got our probability. Now let's see what are the numbers, props. Okay, so as you can see, this is a 5-class classification problem. So we have 5 classes here. So it is the maximum is 0, 1, 2, the second index. All right, or you can say the third index. Cool. So I can do this so that I get the inner array. Cool. Now we can use the np.argmax function to get the maximum value in the array. All right, 2. Okay, it gives us this index number. So you know we had 5 classes. All right, so these were the 5 classes. So what can I do? I can make a function out of all this process. Okay, so what I will do is I will create a function to make it easy, or rather not, I'll just use the indexes. All right, so now we got the index 2. So what we will do that we'll do output index is equal to np.argmax and print classes of output index. All right, oops, class is not defined. I didn't run this cell. Okay, cool. So it is neutral because obviously we didn't train it at all. So after the training process has been completed, it will obviously perform very well. Okay, so I urge you to please train it at least on 5 to 10 epochs, okay, before actually using this model. So yeah, I think you got the idea of how to create your own multi-class classification problem. And yeah, this is all for this tutorial, and I hope you enjoyed it. Thank you.